Hello, good morning, everyone. Great to be here and excited to share some ideas about how you can use the AI in combination with these new things called Model Context Protocol. It's not that new anymore. My name is Christian Tzolov, and I'm co-lead for Spring AI project and one of the maintainers for the MCP Java SDK.
And I'm Dariusz. I work primarily on Project Reactor, but I also team up with the Spring AI team, and we, together with Christian, built the Java SDK for the MCP.
Nice and bumpy road, but exciting one. So without further ado, what are the generative AI LLM used for, and what actually there is a black box? There are a few very important characteristics. They're stateless. They're pre-trained up to some moment in the past. They take text in, text out. I mean, very interesting characteristic that you have to be aware of when you build applications that take advantage of those LLMs. And when you're talking about how you can use the LLMs, indeed, you have to consider a couple of things. Assuming that you have your application will have some your custom data, some custom APIs. One of the problems you have to solve is how to make the LLM aware of your custom data or retrieve your data. Second part is how to make the LLM aware of your API and make use of those APIs. And finally, another important aspect, after all the LLMs are stateless, you have to maintain state across your interactions with the LLMs. Those type of problems are actually integration problems, and anyone here, I believe, is aware that Java and Spring AI have been into this business of solving integration problems. And indeed, Spring AI is the tool set that extends the Spring ecosystem, provide portable abstraction across various AI components and concepts. Starting from the various type of models, image, audio, embedding. We're going to focus more on the chat models today, so the chat abstraction API, vector. And when we talk about the chat models, again, LLM is stateless, so the output of the result of when you use LLM is only as good as the prompt or the context that you pass to the LLM. So this is a very important concept, and a lot of the science and all the experiments goes around how you actually can optimize and provide the better prompts and better context. Spring AI, if you're familiar with the REST client, a web client, chat client coming from the Spring AI would be something that would feel very, very familiar as well, at home with. And prompt indeed is, as you can see, the one of the way to provide and talk with the LLM. It is a portable abstraction. You can very easily change the dependency, different boot starters. The same code, different configuration. It should work most of the time. And now let's see how we can actually use Spring AI to solve one of the problems that we discussed, retrieval, or how to make the LLM aware of your custom data. As you know, the LLMs are pre-trained up to some point in the time. So even if they have some knowledge about your domain, your information, it wouldn't be most recent one. You'd always have to make the LLM aware of your particular information that you would want to ask. And the most simple and powerful technique is called prompt stuffing. Basically, along with your user instructions, you're going to can I point here? User instruction, you're going to stuff some additional context, which would be passed along as a single message, single prompt to the LLM with some additional, perhaps system instructions, telling the LLM to use this context prior any existing knowledge, so that you make sure the LLM is going to inform its answer based on this context. So very straightforward and simple techniques. It has its limitation because the contexts are limited size. So if you want to do something more advanced, most of the time you're going to jump into the concept of retrieval augmented generation. The good news is that Spring AI provides a very deep and full support for modular RAG. The bad news is that this is a talk by itself, and I would advise you to watch this presentation, which provides very deep and insightful details how to use RAG with Spring AI. Going forward, now covering the prompt stuffing in the simple way, how you actually can bring your data with the LLM. What about the second part, the tools? And the tools, we have to keep in mind that, again, LLM is text in, text out. It doesn't know how to call APIs, but most of the modern generative AI models, they've been pre-trained to recognize special type of metadata and return special message instead of final response. So in this case, and I need to use
the tools can be used for actually giving the LLM the power to actually interact with the world, right? It's kind of, we are asking the LLM here about something useful for us, but the LLM has no idea how to do it, right?
Absolutely. So if and this is the example, we are asking what, again, this is some hypothetical use case where we are asking the IOM to help us assist us to book some talks with different conferences. And if IOM doesn't know anything about the conference, particular recent time, real time, most likely you make up something or say that it cannot answer our question. So we can remedy or make the LLMs aware that actually we might have a tools or one or many tools that actually can provide this real-time information, allowing the LLM requesting, updating its prompt with some more recent information so that it would be able to provide us with more informed and concise response. So if we ask something like this and we provide in this case this tool, we say along with our instruction in our prompt, we can pass a metadata that has information. We have a tool called in this case ticket booking tool that has certain description. Description is a very important parameter for the tool definitions because this is the hint for LLM when it should use and if it should use certain tools. And the input, this is the signature of the parameters that this tool would accept, usually expressed as a JSON schema or OpenAPI schema. So based on this information, generative AI or LLM would realize that it needs this additional information. Instead providing the final response, it would actually send us a special tool calling response, intermediate output, saying something like this: okay, please, you pretend to have this tool, which is defined, please call this tool with ticket booking with this particular input parameters. Then you as an application developer, you're supposed to use this information to dispatch to figure out how to obtain the information for this tool, checking database, retrieving from database, using third-party APIs or any other means to get this data. You have to obtain the response and return it to the LLM. But again, LLM is stateless, so this is not enough. You really have to provide the context, the history of the previous conversation for the LLM to be complete. So it's a reactive system that only acts upon the inputs you provide. So it's user or application developers, AI application developers, to provide this context, and finally it would provide some meaningful response. The good news is that framework like Spring AI and similar, they will take the burden of all these interactions of the tool calling. So for the end user, you would have the request that comes with the definition of tools that are supported and the response. So it would feel like a single short request response, while the framework underneath would dispatch all intermediate tool calls, codes the tools, maintains the context, and do all the plumbing that is required.
So Spring AI remembers what's happening, and then it can deliver the response back together with what happened.
Yeah, and it knows how to detect the special messages, dispatch it to the right tools, code the tools, get the context, and assemble the right message.
What if I don't want the LLM to know something?
That's very important. So it's very important to realize, and this is a good point, that the tool calling and the tools are owned by the LLM. So we, as an application developer, can provide information about the existence of tools, their description, their arguments, but it is the LLM that decides in what case, if, and in what order to call the tools, and what parameters to pass those tools. So this is here, you see this line that IOM calls a tool, but there is a cases where you would like to add the additional parameters to your tool calling that doesn't come from the IOM, usually some session ID, secrets, bits that comes from the user application, but not the LLM itself. You don't share this, and there is this concept of tool context in Spring AI, which transfers very well with, later on you see something that is called the MCP meta model request, meta request parameter, which allows you to pass this additional information in your tool request to happen. And we'll demonstrate this in a bit with very short applications. So again, going back to the same use case, we are having a simple conference assistant application.
So I want to go to conferences that essentially talk about MCP, because that's what interests me, right? And everyone here. So how would this be done with Spring AI?
Yeah, so we have the same two problems. We have to figure out how to provide the relevant information, the context, with the LLM when we ask this context. This is the prompt stuffing techniques. And secondly, we have to provide a set of tools that would allow the LLM to go and register and book those conferences, any additional functionality, actions that actually to interact with the environment to do so.
So you're going to build an application that has the agendas of the conferences?
Yeah, that's what we're going to have.
And it's going to have access to some booking service. And I'm just going to ask the tool that you're building to provide me the tickets.
Yeah, you're this guy here without face.
Awesome.
So how this looks in code. Be careful. So here we have a simple Spring AI application. Let's make it a little bit. Is it readable enough? Hopefully it is. So it's this typical boot application. As you can see, we have enabled a Spring AI chat client boot starter, pre-configured with one, I'm not sure, either Anthropic, OpenAI, or any other supported models. In this case, so the Spring boot would inject this builder for us, and it would allow us to interact with the LLM behind. So first thing we are going to do, we're going to get the resources. In this case, this is agendas, which I collected from various conferences we've been attending this year that all have topics about MCP.
And they're all in different formats,
that's
right?
interesting bit. So I didn't pay attention to try to structure them, just
and you put them all in the application, but it could be stored in a database that we would have to integrate in our app, right?
Yeah, you can be a database, or as I mentioned earlier, if you want to build something more mature, most likely you're going to involve RAG and something can pre-index this bit. So, but that's kind of beyond. And
we are doing prompt stuffing, which is the simplest. Just put everything in the context that we send to the LLM.
Yeah, that's it. So we are reading these resources. This is the Spring resource concept we are getting from the file, and then we are building our chat client, so prompt with some system instructions which provide the general ground truth for this LLM, how to behave across our interactions. And here is the simple user instruction. I want to attend all talks mentioning MCP. Here are the list of agendas from various conferences, and we have.
So that's exactly how they're stuffed. Like they are directly in the text that's going to go to the LLM.
We're literally stuffing the content of all these conferences, schedules of all these conferences into our prompt. Additionally, so this is practically the prompt stuffing bit that we discussed earlier. Then how we actually can make the LLM aware of our tools.
And how can it book the conference for us?
Yeah, it's very simple. So for this, we have built a very simple booking abstraction or tools. It is here, so it is again injected as a dependency. It is practically this service, and under the hood is using Java Spring service with some mocked-up database. It's a tool annotation, which is with the description, very important part, as I mentioned. This is the hint, the metadata mini prompt that tells LLM when to use this tool.
Because the LLM just understands text, it needs to have a textual representation of what's this actually for.
Absolutely. And the input parameter, and this is the magical text context. In this case, it's optional, but it allows us to pass some additional information or send some additional parameters to the tools that doesn't come from the LLM. In this case, this is the username that we actually were sending the application, and we booked the conference for this user. So with this, and anytime we code, so practically we're defining the list of tools, and anytime we perform a chat client call, we can actually pass parameters through this context that are coming from us as application developers, not from the LLM. And let's go ahead. I think we have all bits, and we can
let's see it in action.
Yeah, let's see how this runs.
And hope the network works.
As you can see, I'm using my mobile network. Hopefully this was a good choice.
Let's zoom a little bit. It might be difficult to read.
Yep, and let's close. So, under the hood, you see that actually our
Can you zoom in a little bit?
Absolutely, can I? Okay. But now, okay, so booking. So you can see that actually this is our tools were called a couple of times. And finally, once all tools have been executed, all booking have happened, the LLM provided us with some information about what has been done and what are the conferences. A lot of topics.
So
about
it actually
MCP.
booked me some tickets for conferences, and it told me what actually are the talks that I might be interested in attending.
Yeah,
awesome.
So very simple and straightforward things. Kind of abstract application, but it also gives you the idea about the whole concept of integrations and the basic things you can do in order to make LLM useful for your particular domain. So, where are we? So
I am impressed. Like we've built an application together, and I can book tickets with it. But I think there's quite a lot of things I needed to do if I was the developer, right?
Yeah.
So my application now integrates with all these tools. It has to do the prompt stuffing with all the documents that there are. How about if I was in the conference business and I was preparing agendas and I would like people to be able to book tickets for the conferences? What if I was building my service that I provide the conference agendas with and provide the tools with a different language, let's say TypeScript, Python, or whichever else I'm using?
could I use Spring AI to talk to that tool? I would need to build an integration for it, right?
Yeah. Practically, you have to. Yeah, you'd be forced to integrate into.
So find
your
out what the
responsibility
APIs
to,
are and how to prepare it for the actual tool.
Or security, and you should know how to use these tools, how they work, and so it's your responsibility. You're AI developer, but also integrator for all this backend system you'd like to enable your AI to has the capabilities. Yeah.
On the other hand, if I am actually building the application that's AI enabled, it talks to the LLM and it allows users to ask different things, probably things I haven't thought about before, but it can take advantage of all the knowledge about the conference agendas, the speakers, etc., and I built it with Spring AI.
But
can someone use it?
It's hard. Someone can try to build in different languages and stuff, but it's more like a silo. Everyone is building their own tools for their own system and repeating itself. Yeah.
So let's say I'm building the service with Spring AI to actually serve the conference agendas, and you're building the tool, or I want Claude AI to use it. In that case, what are the other things like the resources? So they can be file system resources, they can be database resources, and also you needed to type that prompt. What if you had a set of prompts that you wanted to embed in the application, but you didn't want to?
That's a good point. And very often, even if you're using the same code and you change the model, most likely you would have to change the different prompts. So all these prompt configurations is something that you would like most likely to offset and
you might manage in a database, right?
Manage, rather than having it in the source code.
So is there a solution that unifies this problem? Well, that's why we came here. And if we zoom out a little bit and think about what kind of a problem we are solving, that's actually focused on the prompt. And the prompt is just a textual window that's limited in size that actually we call the model context. It's everything that the model knows. It needs to have the conversation history. It needs to have the metadata about the tools. So let's focus a little bit on that aspect and what it is comprised of. First of all, there's the system instructions. In our case, we told the LLM that this is a conference assistant and it's going to be helpful to make bookings. There's also the user instructions, so what the user wants. In my case, I was actually interested in going to conferences which mention MCP. And the additional data, well, that was the resources that we gave it with prompt stuffing. That was the agendas that we had. And there's also the memory. We're not going to talk about that, but if you want the model to remember what happened, you need to give it some data.
Spring AI has a very, very elaborate support for memories and abstractions, but this again beyond. Go to the reference documentation and find different way you can extend it.
Yeah, and we mentioned tools metadata, so now the LLM can have an effect on the world. So with all of that, how can we abstract away the AI application away from these tools, resources, and prompts, and enable application developers to form two different communities where on one hand, we build AI applications, and on the other hand, we separate the concern of providing the vendor-specific information to the LLM-enabled applications, and we introduce an architectural concept, which is called the Model Context Protocol. It's being talked about because of its utility. It can separate the tools, resources away from the concerns of the application developer. And if we look at what was the case when you built it with Spring AI initially, you had
nice monolith.
You had one AI application that needed to talk to the database. Well, we embedded the files, right? But we had to get the files. We had to integrate with that system somehow. There's all these other concerns, public APIs, external APIs that we might want to use to make the conference booking, and so on and so on. So in every application that we want to combine, integrate with these systems, we have to do a lot of work. So this is quite a complicated problem. If we decouple this into two different parties, then we put a common protocol that abstracts away these concepts. And based on that, now we have a simpler problem to solve. On one hand, at a different pace, the AI application developer can build their app, and the service provider can expose the resources and tool capabilities on their own end and manage the lifecycle separately, as long as they communicate using the common vocabulary
protocol. Yeah.
So the problem is much simplified.
Yeah, we reduce it.
We saw the advantage of MCP, and early on we decided to start to integrate Spring AI with it. And we managed to create the official Java SDK together with Anthropic. We contributed that to the community.
And we're maintaining it, so it's kind of bumpy road and very exciting road. But
yeah, it's a very vibrant world with AI, and the community is also very engaged. We have more contributions and more contributions coming, so it's a great time to actually be an AI developer. So in Spring AI, the MCP has become the foundation for a lot of capabilities that there are, and you can easily use it with annotations that are MCP specific, and you can use them in your application, both client applications and server applications. So
can you tell me a little bit more about what actually MCP components are? So what are the downstairs? So before we dive into
I'll tell you now, because this is where we look at both parts. So there's the MCP server. So when you have an API that you have been exposing and now you want to tailor it towards a model use, so that's a different paradigm. You cannot just open up the open API and hope the model is going to be able to figure out what to do with it. You need to write some text that's very descriptive for the LLM, and you need to prepare the resources in a particular way. And that's what the MCP server side of the protocol entails. So for each different vendor and the capabilities they want to expose, they can have an MCP server layer that exposes those.
Does the service providers are responsible or supposed to be very familiar with LLMs and AI development?
Not really, right? They just expose. They are meant to expose the MCP.
They know very well their own APIs, and they just provide this unified wrapper around it. So.
Right. And on the other end, there's a connector on in a host application, the AI application. You have the MCP client, which connects to a particular MCP server and takes care of the communication and the elaborate scenarios that you might run into if you are building on top of MCP. And as I mentioned, in Spring AI, you can cater for both client-side applications, so those rich LLM-enabled applications, but also you can be on the other end where you expose the existing APIs, databases, and your resources as an MCP server developer.
So, let's dive a little bit more. So we're talking about the server and server community, server sets of capabilities that can be exposed, and the client side of these capabilities.
This is quite interesting, right? Because it's a dynamic protocol. It allows to build quite interesting things. So on the server side, the server can expose tools. We've seen the conference booking. That's one type of tool. So the LLM has the ability to take actions on the world. There's the resources, so we have seen the conference agendas. There's all sorts of things that you can expose as files, as custom data that can be identified as URIs. And there's prompts, so you can have a database of well-prepared prompts that are specific to your business use case or whatever you are building. And there's other capabilities of the MCP server, and the community keeps coming up with more ideas. So let's focus on what the MCP client capabilities are, because now the interaction becomes dynamic and very vibrant, because the client can also do things on behalf of the server, because the MCP client is the application, is the part where the AI application has access to the LLM. So imagine a situation that the MCP server developer wants to actually ask the LLM, the model that is in control of the application developer, let's say Claude AI, to actually summarize something or do something creative. So it can use sampling. That's a very interesting capability. So when you call a tool or access any other resource or capability on the server side, the server can decide to sample the LLM for some data. There's also the ability to ask the user for more data. So
elicitation, this is a new feature that is just
quite recent. So there are cases when the MCP server needs some additional information, like ask you for how much would you like to spend for the tickets, for instance, right? So it can be a more elaborate scenario where the user is asked something, and then the MCP server is given more information. And there's other shared features that can make the protocol actually quite dynamic in form of the progress and so on. So all of that is built on pluggable transports, which have an interesting evolution. The whole model context protocol has started with desktop applications. So the very first transport was built on top of standard input, standard output between two processes using POSIX pipes. And that has been quite limiting for more elaborate scenarios in the enterprise. So new ideas came to be for remote deployments. If you want to deploy a server that you want to expose to the users of an LLM.
Well, we're using the same concept of pipes in and out one. So
yeah, you can deploy it on a completely different machine and now make a connection between them using something that's built on HTTP. Why? Because HTTP is the language of the network, and the creators of MCP were very eager to have everyone on board because it's very useful and you can build LLM-enabled applications in all sorts of languages. So every language typically has an HTTP client and can serve HTTP. So there's a bit of a story here. We'll talk about that in a bit, which is important when you actually get to deploying this. But the first iteration of remote calling was server-sent events capability with HTTP, and that turned out to be a bit limiting. So now the current proposed protocol is streamable-HTTP, which allows quite interesting interactions. We'll talk about that in a moment, but I'm really eager to dive into a bit more interesting case.
Yeah,
how this works in practice, right?
Yeah, so we mentioned about this bidirectionality, the sampling capabilities, and how actually the server can take advantage. Normally, the server, when you build a server, again, the server doesn't know anything about IOM. You don't want to repeat all these complicated configurations and stuff to make the server implement AI applications. So server just focus on its domain, its third-party application wrapping. But in some cases, it would like to, you may want to have a creative response and extension of the information that the server provides. In order to get this creative response, you have to talk to the LLM, and for this you're going to use the sampling, this bidirectional, and it's a very intricate sequence of flow of information. So
let's see what happens.
Works, yeah.
The LLM decides to call a tool. I want to book tickets. And the MCP client is the one that talks to the LLM, but it needs to call the tool on the MCP server. So that's the next request that comes in. And the MCP server now wants to extract some information out of the LLM, so it has to go through the client to ask for sample of the LLM capabilities to provide some creative data. The client proxies that back to the LLM. The response comes back, luckily, and it proxies that forward to the MCP server, which now can fulfill the promise of the tool call, and that actually goes 2 steps back to the LLM, which can finalize the response that was initially
This is one.
created.
Elicitation works in very similar way, but instead of the LLM, in this diagram, you would have the user
right?
application that would have to
I want to
support.
see this in action. I'm a bit,
Yeah, too much talking.
keen,
so let's
to see some code.
So let's try to extend our existing monolithic application and see if how can we take advantage of the MCP to build and split our code into the service and client-side responsibility, application responsibility. We're going to wear 2 hats. So we're going to create a MCP server that would expose the tools that we are aware and manage the resources for us and provide unified MCP endpoint using streamable-HTTP as a transport. On the client side, we're going to register to this server, use these capabilities, and do all the other chat client LLM configuration that we aware. Also, in our case, we are going to take advantage of the MCP client capabilities, enabling sampling, logging in progress to help this bidirectional interaction and rich communication between both parties. Let's wear our service provider responsibilities hat first and build the server part of our application. Okay, this is a little bit too much. Let's close this. And so it is our new project. So first we're going to build a server, yet another boot application.
So it's a typical boot application, right?
Yeah. And we are and here we are building our server resource capabilities.
So these are the conference agendas that you can
we are mocking up the
serve
same concept. It could be a database, but now we are taking advantage of the resource concept provided by MCP. And actually, we're defining 2 types of resources. First one is a static resource. We just provide us the list of available conference documents. This is the URI and then we have a second resource which actually use dynamic URIs. In this case, based on the conference name, it can provide us the content of this this conference itself. So this is solving our prompt stuffing or resource management part of our problem, and now we offloaded this on the server side. Very straightforward. What about the tools? Again, we can expand on the concept of tools using now the MCP paradigms. So instead of the add tools, which is typical Spring AI concept, you still can use add tools and it would work for the MCP servers, but you won't be able to use some of the advanced capabilities like the bidirectional exchange. For this, you would really need to opt for the more idiomatic MCP tools annotation that would allow you to inject, for example, context like this. So along with your parameters, you'd be...
So essentially, you're building the booking service now, right?
Yeah, it is the booking service, the same tool that we had before.
So the LLM calls this
when it wants to book a service for us for certain conference name.
So you have a description there that says what this is for.
Yeah, okay. It's very important to have the description. Optionally, you can have description for the parameters because the LLM designs and fills in the parameters. You can also pass additional parameters that comes through the metadata of the request. This is the MCP. All MCP requests types. They
so
have
that
this
would be the username from our previous example that the LLM doesn't need to know.
So practically Spring AI under the hood would convert all two contexts defined on the client side into meta parameters that you can receive and process on the server side. And this is the information that comes outbound about the username that would come from our application, which is also required in order to make the booking. So what else we can do now? This context allows us to send a log information back to the client. And yeah, I'll show in a bit how the client received this and handle this type of log.
So the client application can actually log the information that the booking is happening.
Yeah, this. Then we actually perform the actual booking, just updating our local mocked-up database. And we're performing this advanced sampling part. This is the interesting bit. So now we would like the LLM to generate for us some sort of summary for this particular conference or this particular schedule as a part of our booking and part of the information.
So we're stuffing again the agenda here.
Yeah, so we are practically using the agenda that has been retrieved, and we are stuffing and we're sending actually message back by sampling to the client, which will delegate it to the LLM, get the response.
We've seen that diagram.
Yeah, and once we have the response, we can actually return and finalize the tool calling. So I think we covered the stuffing and the tools. Now,
so what is the response composed of? Because this is what the LLM is going to get as the actual response to the tool call.
Yeah, after successful booking and after successful sampling, summarizing of this conference, the LLM would receive the conference name and the content of the summarization.
So the summary, it can say something interesting. I'm really curious to find out what the LLM thinks.
Everyone is so. Let's start this application and
how did it? So we're not covering the client yet. This is just the service.
Yeah, but that's the beauty. Right. So now we don't have to think about the client application. We can build this and we can test it with something like, I presume you already have seen it already, something called MCP Inspector, which everyone it's been even running. Let's restart it again, which is a tool that universal client is part of the ecosystem for MCP. And let's zoom this. We can use streamable-HTTP, connect to our endpoint, and let's connect. Once we are connected, it's a very handy tool, so we can list, so you can see the initialization, logging has happened with the server. We can list the available resources. In our case, this. Let's zoom this a bit, like this. So this is the list of our conference. We also have this, it's called resource templates in the terminology of the MCP, which is practically dynamic resource URIs. And you can even retrieve the content of some of those resources. We also can list the tools available. We can code the tools by name. So you already can explore, interact, and test your system without even touching LLM at that point. So this is the beauty of this separation of the console. But let's now wear our AI application developer hat and see what we can do on the client side. So while the server is running, let's keep it running. we can actually see how we can build a client that connects to this and actually fulfills our premise to supports our conference assistance.
So we are
case.
building the chat application, right? This is going to be a
Sort
CLI
of the, yeah,
application,
so,
similar
yes,
to the one before, but we no longer have to worry about all these resources and tools.
Yet another boring chat application, but maybe useful. Here is the application. It is Spring, again, very similar to what we used to have. The boot application, we inject our chat client so our AI application can talk with the LOM. And under the hood, we are injecting two additional our tools. And
where do they come from?
So this is interesting part. So how these tools, you see that we don't have tool definition here, but by connecting to our, so this is how actually we make our application connect to this server, and you can have multiple clients connecting to different servers with different transport protocols. In this case, we're using the streamable-HTTP, and this connection name is called conference assistance.
So we just configure Spring AI to have another remote service to use.
The Spring AI under the hood is going to use this information to spin up a new MCP client, connect to the server, and allow you to obtain and, for example, list tools, list resources, and all this additional information. In the case of tools, it's automatically going to convert this information into two callbacks and two providers. And this is exactly what you're going to see here injected as a MCP tool provider. So we're using this tool to pass it to our chat client somewhere. It is here, indeed. Let's close this bit. So the second part, so this was the tools. They came practically outwired from the fact that we connected to this MCP. There is a different mechanism to pre-filter the tools. Most of the time, if you connect to the different MCP server and stuff, you don't want to have all the tools automatically enabled to your application. So it's nice for demos, but in reality, you would like to be much more restrictive about what you expose to the LLMs. Second part, again, is the stuffing part. How actually?
So we have the prompt. We are asking the model to find MCP conferences for us that we want to attend those conferences.
We want to attend, so we expect
MCP.
the LLM to book for us this conference. So this would presume using some of the tools that we expose, and we're kind of restricting the scope, asking the LLM to be a little bit more intelligent.
So there's specific conferences we want to go to, including DevOps, right?
Yeah, absolutely, of course. Maybe you should have been the first one.
So that is the prompt, and you add some additional context over there.
So this is the concept of the prompt stuffing, concept of the prompt stuffing. But now the resources are not managed on the client side or the AI developer side, but actually are resources that the AI developer can use and retrieve from the server. In this case, and we are using this MCP conference service. Yeah, so practically what you see here, and let's again zoom, it is we are using the native API, MCP chat client, for SDK API in order to talk to the server and retrieve. This was one of the resources. Practically, we're getting very boring OIDs of the resources, and for OIDs, we are practically creating the list of the contents, which we can.
So all the agendas are being pushed to a list, and that's what we are injecting inside our prompt.
Just to illustrate how you can do it.
But now we don't have to have them in place, but we just communicate
they're managed
with MCP with the server to get that.
And you have to be aware that also MCP is a dynamic protocol. You can have and subscribe for notifications about change resource, change tools, change prompts. So practically the client can be aware of any communication and can adjust and update if necessary. It's very powerful, but at the same time controversial techniques. How suddenly your client, without restarting or anything, can acquire new tool capabilities that is not aware. So maybe you should have some control on these bits when you implement your application. But it's very interesting and exciting dynamic schema. So we have these bits inside. So
can we see this in action? I want to see how these things communicate.
So we have all these bits. And again, we're injecting the tool context username. This is this side outbound information that is not coming from the LLM, which internally is going to be converted into the request metadata that our tools is using to.
That was the argument.
Yeah, that was
the server side MCP tool annotation, and then the arguments.
Okay, but before we go to running this application, how we handle, we saw that the server is sending logging message, sending the sampling message to the client, how actually the client can support this special events that comes from the server. So Spring AI provides these kind of handy abstractions like for logging, sampling, elicitations, progress you can have. And so in this case, this is a handler that would listen for log messages from the server. And in this case, you can even specify scope down what are the which server of the many connections you have. This handler should support. You can actually have a list of multiple servers if this handler should be reused across multiple applications. And this is the most interesting part, actually the sampling handler. So the server would send us a sampling request, practically called the LLM. It can be very rich. The LLM request can contain hints about the preferred LLM the server would like you to use. And the client should provide maybe a set of those bits. So in response, the sampling actually is using the chat client. In this case, we're using the same chat client that we're using for the main AI application. This might not be the case, and maybe may not be very good use case for real applications, but we get the response and sending back to the
So we are
sampling.
forwarding what the server sent to the LLM and returning back to the server.
So practically on the client side, we had all these components and we build these capabilities, and the client doesn't have the capabilities out front or the resources, but it knows how to connect to the MCP servers and obtain what it's needed for him. So
I want to see you click play.
Let's run this bit now and again see what the outcome would be. We're talking to the server. So you see that now our logging handler is already printing. Should I zoom a bit? I'm not sure it's...
Yeah, let's highlight what we are actually talking about.
So here you see the zoom. Then the next interesting thing, our client handler received the sampling request. It replied to it, did the summarization with the help of the LLM to the server, replied to the server. Now the server, maybe you should have include also the progress token to see this slow progress, but the server eventually completed with all this information, and we received these summarizations. You can see that.
So the final response that it gave us, show me here. It says successfully booked tickets. So I'm going.
You're going.
I'm here. It happened.
Yeah, that's the good news. The bad news is that those are kind of past conferences. Sorry, but you can watch them.
DevOps is still happening, and I'm here.
Sure. Okay.
I wonder what it said about DevOps. Did it say something good? A renowned developer conference.
Okay, so
that was not in the agenda, right?
Yeah, so practically you see that indeed the benefit that the LLM is doing something creative and trivial stuff. It actually combines the context that we provided along with some general knowledge about the conference it already possessed.
It did a lot. It booked the tickets, it summarized using the LLM, and it actually is quite useful.
Is it useful? I mean, I believe that it's useful, and let's see where we are. So we try to...
I mean, we're on the stage. We're the masters of the hello world, right? What if I wanted to actually go and deploy an application like this? Is it simple? So if I did deploy this somewhere, if it's my laptop, it's great, right? So the MCP client and MCP server living on the same machine, the typical use would be the desktop application of the chat client, which launches a sub-process on localhost and communicates with standard input, standard output. Let's zoom out a little bit and see how that works. So there's like two asynchronously consumed pipes between these processes that the client sends data to the server needs to read that, and it can send back responses using the other pipe. And that typically in those applications that are, for instance, meant for IDEs that we all do, for language servers, the messaging format was JSON RPC, and the Model Context Protocol developers got inspired by that, also used this quite simple format for exchanging messages that can do requests, responses, notifications. And that messaging format was taken forward to the remote deployment situation, where we have a client-host process that can have multiple MCP clients talking to different MCP servers over the network. And the way to do that, as I mentioned, was using HTTP. And the SSE-based, so server-sent event-based specification that was first, which is now deprecated, had this flow where the client opened an HTTP connection that the server turned into a server-sent events channel that would be used for the server to actually do the communication with the client.
Over JSON RPC.
With JSON RPC as the message format, and the client can communicate to the server sending requests or responses to the request that it received over the HTTP post-initiated connection. And that was all quite nice until you wanted to scale the application. You had more traffic. You wanted to actually see that grow, and you treated your MCP server as a microservice, or you wanted to actually provide some high availability if one of the instances failed. All of that we do. You put a load balancer in between because you don't want the client to know all the IPs of the MCP servers, right, or something different. Then the troubling situation is that one of the responses goes to the other server. And if that happens, then you have to think about solutions. One of the solutions that people came up with was to provide a concept of a session in those communications between the server and the client. The client would know what session the messages belong to, and it would be a different endpoint each time a different client connected. But that still happened to land on a different server. Then you needed to have infrastructural solutions that would solve it. You can think of session stickiness in the load balancer, which might be hard to do if it's not using cookies. You can think of other solutions, such as adding a queue that you would push messages, and it becomes quite chatty. So there's all sorts of infrastructural solutions that you need to come up with.
To try to replicate or database to keep the session status. So it's all this.
The smart people from all around the world, because MCP is quite popular, sat down and thought, what can we do? So they came up with a concept called streamable-HTTP, which is still quite similar to what we've seen before, but it allows some variants of this communication. So again, the client can open with the server a long-running server-sent events channel using HTTP GET, and that turns to be a server-sent events response from the server. And the HTTP post can also be used to send requests to the server and notifications and responses. But this HTTP post can also be a streaming channel. So for a particular request, the server might be able to stream some information back to the client. So progress updates, logging that are related to this request can also happen. And the beauty of it is that the specification of MCP decided finally decide that there is a transport session that is overarching this, and it has been standardized in the HTTP headers. So now you can configure your load balancers with a specific header that can be used for session stickiness, or you can put a middle layer that would use a queue to actually reach the right server. But still, this communication
might be overloaded if you don't need
is something you need to solve in the infrastructure that you build. So there is a different kind. If you are building simple MCP servers that just expose the tools, that just expose resources, but would not do elicitation, would not do sampling, and all these other things that are bidirectional and quite advanced, you might get rid of one of these channels and just use a specific HTTP post request connection to the MCP server.
Application JSON content.
And now, that essentially allows you to scale horizontally without much thinking. But as I said, you lose some of the capabilities. The biggest advantage is now you can scale the MCP server.
This is a fair trade-off, I think.
It is a trade-off,
if your use case doesn't require any advanced features, why should you be bothered to maintain the session and do something more advanced and actually complicate your infrastructure? You always can opt for stateless approach.
So Spring AI allows you to choose between one or the other mode.
Yeah,
depending on your needs. So the recommendation the
SDK which we built allows you to switch between these modes. Spring AI built on top of these capabilities already, so you can do it without.
With Spring AI, it's just a configuration
it's change. It's boot configuration. It's easy to get there. Yeah.
So the recommendation that we can give is, if you are building desktop applications, standard input, standard output is quite simple to use. But if you want to have your MCP client enabled application communicate with the remote server, then go for streamable-HTTP because it's the current standard. It's not deprecated, and it allows this choice. So if you are using the richness of the MCP protocol, use sessions and have the bidirectional flow, and you would need to be worried about the infrastructural challenges that it imposes, which can be solved, but it's the price you pay for the richness. On the other hand, if you just expose the tools, resources, and prompts, from the server to the client, you can easily go with a stateless mode and have a highly scalable.
It was quite requested feature
deployment.
demand, and I can see that a lot of people are using the stateless.
And that actually justified the creation of streamable-HTTP, which is a
this
kind of hidden
mode,
fact.
Yeah, it's kind of special mode that is apparently very popular for many use cases. And SDK and Spring AI allows you to start with the stateless and then gradually extend if your use case requires and make it stateful. So it's pretty trivial to switch between both modes and vice versa, scope down a stateful server into a stateless one.
Right. We learned more on the presentation that was in the morning. You can watch the video if you haven't been there.
Yeah, we
but
recommend this.
I deployed this. Did I miss something?
I think you touched about the interesting enterprise concept about the deployment, but there is another, along with the stateless mode, and there is another very important feature that SDK has been asked. I mean, after all, you're having the client-server applications, servers that provide various tools, various resources that you are randomly plugging into your applications, and you most likely would like to have some sort of authentication authorization about this with fine-grained access to different resources that expose different tools, the tenants' relationship with these tools, and the specification come with, the MCP specification come with binding the OAuth 2 resource servers as a means to ensure this sort of guarantees.
Can I use Spring Security for that?
Actually, you can use Spring Security, but Spring Security is using extensions, actually, bits that we built into the Java SDK. That
so you can swap out Spring with the Java SDK for something else, and you can authorize using your tool of choice that provides the reliability.
Actually, the stack of choice, you know that the Java ecosystem is quite rich in different stacks and different solutions. So the SDK itself allows you to provide the security hooks that allow to propagate the security information across the important parties and entities. But then you can use this to build, for example, our friend Daniel built MCP security based on the Spring Security extension that is very functional and very interesting. So you can visit his blog. The project is now served into very interesting part of. I would like. Oh, we are running out of time, so let's go ahead. His talk is after hours, so I highly recommend you to visit if you want to understand better the deep dive instructions. So this is the talk in stuff, and I'm definitely going to be there. So hopefully this would be useful for you. Find some resources to read more. Can you reach out back to us, and we would love to answer more questions.
Right, thanks.
Thank you.